All right, so a couple things before we get into answering question number 1. These two symbols up here, P and mu, we use to represent the true proportion and the true mean for all people in our population. We call these things parameters. These are parameters. They're called parameters because they come from the population. Right. These two things, P and mu, are called parameters because they come from the population. And I apologize, guys, my board is acting up today. I'm going to do my best to keep us where we need to be, but sometimes the board is not going to be showing what I'm writing. But I would like you guys to circle these two, P and mu. This is the true proportion and the true mean for all AP Stats students in this district. These are both called parameters. What does each dot in this dot plot represent? A student who took the AP exam and their score on that AP exam. We call this the population distribution. Population distribution. And as Aiden said, each of those dots represents one AP Stats exam score for one of the students in this district. Sorry, guys. I'm doing my best to get this up. One AP Stats exam score for one of the students in this district. There we go. All right. So far, so good? All right, then I had you guys take your samples. I want you to start copying down the dot plot in your notes. There's just a couple that I need to go and get. You do not have to count the exact number of dots. I want you to get the approximate shape in. 7, 5, and all. Okay. 7, 5, and all. Please go ahead and get the approximate shape sketched into your notes. It is okay if it's not perfect.
How many are at 6?
Yeah, we're just approximating. I'm working on getting it up, hon. I have no control over this. This is my board acting up today. That's okay. I'm doing my best. I'm trying to keep my cool. I about lost it during 5th period because it was acting up over and over and over. I think I have now dealt with the fact that it's going to continue to act up, so I wouldn't go that far. I, however, am not going to lose my temper at the board, which is saying something right now. Because this is what it's doing to me. All right. Working on getting this up. It's, I can try, but it's the program itself that's acting up. So I have restarted my computer and I have turned the program off now 8 times. I have logged out of it and logged back into it. I'm not entirely certain why it's acting up. It was doing this last week, but then it wasn't doing it earlier today. And then when I left to go to lunch, this board turned itself off. And ever since then, it has been acting up. These values up here, the proportions that we calculated, We call each of these a p hat. Each of these is a p hat value. Again, you don't have to get the exact number of dots, just get the basic shape in. That's perfectly fine. What did we say p meant up in that box up at the top? The true proportion. So I'd have to look at that page with all 253 scores on it. I'd have to go through and highlight all the 3s, 4s, and 5s. P hat is not the true proportion. What is p hat? Estimated proportion. Where did we get these estimates from?
Just picking a random sample.
Picking a random sample of?
Scores.
How many scores?
10.
10. In this case, our p hat is the proportion out of 10. So each one of these dots that we put on our dot plot, each one of these is a different p hat. Each one of these is a different p hat. Each dot represents one random sample of 10 students and a proportion calculated from that sample. We call these statistics because they come from the sample. If I calculate a number from a sample, we call that number a statistic. Whether it's a p hat or these sample averages that we calculated over here, we would call these x bar. Those proportions and averages are statistics. We are going to use these statistics to try to estimate p and mu, to try to estimate the true proportion and the true average. Looking at the dot plot that we came up with, if I asked you to use this dot plot to estimate what you think the true proportion is, what would you tell me? 0.62, somewhere between 0.6 and 0.7. Does that seem reasonable based on our dot plot?
Yes.
Yeah. We call this a sampling distribution. This is a sampling distribution of p hat. Sampling distribution of p hat. As opposed to the dot plot that we had up at the top of the page. What did I say the dot plot at the top of the page was? The population distribution. That was every single person got one dot. A sampling distribution, and technically this is only part of a sampling distribution. A true sampling distribution would have every single average calculated from every single possible group of size 10 in this population.
But that would be insane.
That would be insane, so we only have a partial sampling distribution here. But as I create my partial sampling distribution, I can begin to see what the true population proportion probably is. All right. Let's go and look now at the dot plot for the means. And I'm going to have to come around the room. You guys can create this the same time I'm drawing it. So now I'm looking at the means, the averages. You had 2.9, 3.3, and 2.7. All right, what were your averages?
2.7, 3.2, 3.9.
All right. Please go ahead and create this dot plot at the same time that I'm coming around and recording these numbers. You had 2.9, 3.3, and 2.7, 2.9, 3.3, and 2.7. .4, 3.3, and 3.1. You had 2.9, 3.3, and 2.7. 2.9, 3.2, and 2.7. Thank you. All right, just a couple more dots to go. And this should catch up here in just a second. It's running laggy. 2.2, 2.4, 3.3, and 2.9. You had 3.4, 2.8, and 3.7. 3.3, 2.7, 2.9, 2.5, 2.7, 2.9, 2.4, 3.5, and 3.1. All right, there's our dot plot. There is our dot plot. Please copy this to the best of your ability into your notes. It does not have to be perfect. You should have the same basic shape, though. Should have the same basic shape. This would be called the sampling distribution of X bar. The sampling distribution of X bar. Something like that. Again, just get the basic shape. Then the exact number of dots is not the important takeaway here.
You said it was sampling distribution of X bar.
Sampling distribution of X bar, so an X with a line over the top is what we would call this. Each one of these dots represents a different X bar. Each one of these dots represents a different X bar. Hold on. I don't know why it just did that, but I'm going to see if I can't get it back to the correct screen. On the one hand, I'm happy it wasn't doing this morning, but I just wish it wasn't doing it now. Hold on. It'll come back up. Give it a second.
Wait, is it X bar?
X bar, an X with a line over the top.
Oh, I thought it was X half.
No, it's an X with a little line over the top. Is X bar. Come on. You can do it. While my program is thinking about itself, what does each one of these little dots on our third dot plot represent? A random sample of 10. And the mean calculated from that random sample. One random sample of 10 students and the mean calculated from that sample. Give me another word for mean. Average. All right. We are trying. Please, program, please start to work. Right, again, down on number 6, what I want you to write is one random sample of 10 students and a mean calculated from that sample. One random sample of 10 students and a mean calculated from that sample. Okay. I don't know if this is gonna come back to us or not. Did you guys get the sentence written down for number 6?
Yeah.
Okay. I want you to draw a couple arrows to individual dots, and I want you to label them as X bars. So X with a little line over the top. Each one of those dots is an X bar.
The programmer.
It is having difficulties today. I am frustrated with it. I don't know why it's doing this. Like I said, I've turned my computer off twice now. I've closed the program. I've logged out of the program. I've restarted everything. I've done that 7 or 8 times at this point.
Maybe it's the Wi-Fi.
It might be the Wi-Fi, and I would not be surprised at all if it was the Wi-Fi.
The Wi-Fi really sucks.
All right. Go ahead and flip the page over. Let's look at page 4. Let me see if I can get this to do anything. No, still not functioning. All right. I want you to look up at the quick notes box. A statistic is used to estimate a parameter. What are the 3 symbols that are listed there that get used for parameters?
P hat, X bar.
For parameters.
P hat, C.
P. What does P represent again?
Oh, proportion.
The true population proportion. This would be for everybody in the population. What does mu represent? The mean, the true mean for the entire population. What does sigma represent?
Standard deviation.
True standard deviation. What statistic would we use to estimate P? P hat. P hat would be a proportion calculated from a sample. What symbol do we use to estimate X bar? Or sorry, to estimate mu.
X bar.
X bar, there we go. X bar is an average calculated from a sample. We use it to estimate mu. What do we use to estimate sigma? S. S would be the sample standard deviation. Right. Let's go down and check out the check your understanding. I want to kind of work through this together. Maybe my board will respond, maybe it won't. Sorry. I will be posting all the notes in case you don't get things written down exactly the way we talk about it. All the notes will be posted in Canvas, so you can go back and get in all those little details. It says for each scenario, identify the population, the parameter, the sample, and the statistic. Use correct notation for the parameter and the statistic. Number 1 says the Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their family need to get by. The average amount for the sample was $85,000. What is the population here?
1,013.
All adults in the U.S.
All adults in the U.S. The population is all adults in the U.S. Please write that down on the population line. All adults in the U.S. Yes, the sample is the 1,013 adults in the U.S. What is it that we want to know?
The annual.
Look at the very last sentence. Says the average amount for the sample. So the thing that we're interested in is the average for what?
The entire United States.
The entire US. So I'm going to say mu equals, I need to use my correct symbol, mu equals,
For what,
on parameter, yes. Mu equals true mean income or true average income. It changed, but it's still not right. We got something new up. Oh, no, we're back to the old wrong thing. What symbol would we use for the statistic here? X bar. And what would X bar be for this study? 85,000. X bar would be 85,000. X bar equals $85,000, yes. And I would go ahead and put the dollar symbol with that too. Anytime we can include units, we want to include units. Number 2, the parameter is mu equals true mean income. Mu equals true mean income. You're welcome. Number 2, same setup. The Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their family needs to get by. The standard deviation amount for the sample was 15,300. What's the population?
All US adults.
Yes, all adults in the US, or all US adults. What would the sample be? Yes, 1,013 adults in the US. What symbol would we use to represent the parameter here? Sigma, yes, that lowercase sigma. So we're going to have lowercase sigma equals
True standard deviation.
true standard deviation of income. True standard deviation of income.
I thought this was the estimate one, and then this was the true.
This is the true, so that's what we're putting here for the parameter, because the
Oh.
true is a parameter.
Oh, this is the sigma?
Yes, that's a sigma.
Is the statistic just sample average? No, sample standard deviation?
Yes, the statistic would be the sample standard deviation. What symbol would we use to represent the sample standard deviation? S. So S equals $15,300.
So when do we use the other symbol?
When do we use what? When we use the sigma is for the population standard deviation. So that's what's going to go on our parameter line. Yeah, this would be a sigma here, and this would be an S here. Yes, there you go.
So like when you're giving the mean, you'll use that as the parameter.
If you are told what the true mean is for the population, then you would use mu to represent that. Most of the time we don't actually know what that is because the population is so big we can't actually calculate it. So we calculate the sample instead, which would be the X bar. So if we knew the true mean income, then we would use that number here. X bar came from the sample, so we have 85,000 as our X bar.
So because this will give us
The average.
standard, like dimension of standard deviation, that's when you use that for the parameter.
So this says the standard deviation for the sample was 15,300. So we would use S for that because that's a statistic. The standard deviation, or sigma, would be whatever the true standard deviation is. So I would need information from the entire population about what their income is. And then I could calculate the true standard deviation. Oh my gosh, it's working.
But it's also not.
It's not super responsive, but at least we have this much up. All right. Yep, the circle with the little wing off the top, that's a lowercase sigma. That's what we use for the true standard deviation, which we could only calculate this if we had information from the entire population. Because they didn't go and talk to every single person, what they could calculate only came from their sample, and so we call that S. But it's found the exact same way. It's just, where did you get the information from? Did you get it from the whole population, or did you get it from just the sample? All right, let's look down at number 3. Some curious AP students believe that most cars in the school parking lot are silver. They take a random sample of 30 cars and calculate the proportion of the sample that are silver is 0.36. What's our population here?
All cars in the lot?
Yes, all cars in the parking lot. What would the sample be then? 30 cars. What is it that we want to know? The proportion that are silver. Do we just want to know about the proportion in the sample? No. What would my parameter be here? What's the parameter that I've used for proportion anyway?
Proportion of all cars.
True proportion of all cars that are silver. And what symbol would I use for this? P. P equals the true proportion of silver cars. What would my statistic be then? The silver cars in the parking lot. What? 0.36. What symbol am I going to use to represent this? P hat. So I'm going to have P hat equals 0.36. P hat equals 0.36. All right, and then the last question with our last minute here. Students wanted to estimate the average word length for Beyonce's song Crazy in Love. Each student took a random sample of 5 words and calculated the mean of the sample and then used all the sample means to create a dot plot. Does this dot plot represent a population distribution or part of a sampling distribution? This is a sampling distribution because each dot represents what? The mean from a sample. Each dot represents a statistic. In this case, each one would be an X bar from a different random sample. Each dot represents a different X bar, a different statistic from a different random sample. All right. As I mentioned, I'm posting all these notes on Canvas. I think I was able to record a video. We'll see. I will get all of that posted after school today, so please get back in and double check that your notes look like mine. I apologize for the board. I'm so sorry. Hopefully I will have it all figured out by tomorrow. I'll look at it with you. Homework is due on Wednesday. Homework is due on Wednesday.